How Hibernate works in Hibernate. Here you can see how Hibernate works. The Hibernate's success lies in the simplicity of its core concept. At the heart of every interaction between your code and the database lies in the Hibernate session. This image provides an overview of how Hibernate works and don't need any explanation if you have an idea about Hibernate. The heart of any Hibernate application is its configuration. There are two pieces of configuration required in any Hibernate application. One creates the database connections, and the other creates object to table mapping. Let's see the basic introduction to all the component and the roles in Hibernate. Configure the Hibernate connection .cfg.xml. To create connection to the database, Hibernate must know the details of the details of our database, tables, classes, and other mechanics. This information is ideally provided with an XML file, usually named hibernate.cfg.xml, or as simple text file with the name value pairs, usually named hibernate.properties. In XML style, we name this hibernate.cfg.xml we name this file hibernate.cfg.xml so the framework can load the file automatically. And create mapping definitions. Once we have connection configuration ready, next step is to prepare table1.hbm.xml file consisting of Hibernate table mapping definitions. There's a lot going on mapping files. The Hibernate mapping element hold all the classes to the table mapping definitions, etc. So what does Hibernate do with these properties files? And the Hibernate framework loads this file to create a session factory, which is thread safe global factory class for creating sessions. We should ideally create a single session factory and share it across the application. Note that the session factory is defined for one and only one database. For instance, if you have another database alongside MySQL, you should define relevant configuration in hibernate.hbm.xml to create separate session factory for that database too. The goal of the session factory is to create session objects. Session is a gateway to our database. It is the session's job to take care of all database operations such as saving, loading, and retrieving records from relevant tables. The framework also maintains a transactional transnational medium around our application. The operations involving on the database across access we wrapped up in a single unit of work called a transaction. So all the operations that transaction are either successful or rolled back. Keep in mind that the configuration is used to create session via a session factory instance. Before we move on, note that the session objects are not thread safe and therefore should not be shared across different classes. The Hibernate session embodies the concept of a persistent service or persistence manager that can be used to query and perform insert, update, and delete operations on instances of class mapped by Hibernate. In an ORM tool, you perform all of these interactions using object-oriented semantics. That is, you no longer are referring to tables and columns, but you use the classes and object properties. As its name implies, the session is a short-lived lightweight object used as a bridge during a conversation between the application and the database. The session wraps the underlying JDBC connector or J2E data source, and it serves as first cache for persistent object bound to it. Session factory. Hibernate requires that you provide it with the information required to connect each database being used by the application, as well as which classes are mapped to the given database. Each one of these database specific configuration files along with the associated class mappings are compiled and cached by the session factory, which is used to retrieve Hibernate sessions. The session factory is a heavyweight object that should ideally be created only once, since it is an expensive and slow operation and made available to the application code that needs to perform persistence operations. Each session factory is configured to work with a certain database performed by using and provided Hibernate dialects. The choice of Hibernate dialect is important when it's come to using database specific features like native primary key generation schemes or session locking. At the time of the writing, here we are considering version 3.1 supports 2.22 database dialects. Each of the dialects implementations are in the package org.hibernate.dialect. Hibernate object mappings. Hibernate specifies how each object state is retrieved and stored in a database via an XML configuration file. Hibernate mappings are loaded at startup and are cached in the session factory. Each mapping specifies a variety of parameters related to the persistent lifecycle of instance of the mapped class, such as primary key mapping and generation scheme, object field to table column mapping, associations, collections, caching settings, custom SQL, store procedure calls, filters, parameterized queries, and more. Here you can see .csv.xml here loaded to create Hibernate configuration for database 1 here. Hibernate configuration for database 1 is connected to database 1 here. Here .csv.xml defines database specific settings and groups HBMs for given database. .cfg.xml is connected to here class 1.hmb.xml, class 2.hmb.xml, etc. Here the .cfg.xml is connected loaded to create Hibernate configuration for database 2, and Hibernate configuration to the database 2 is connected to database 2 work database 2 work with multiple databases. Hibernate configuration for database 2 is connected to basically here Hibernate configuration object is used to create factory here singleton per database. Factory is connected to session interacts with the tables and classes via bridge. Now this is the end of my presentation. Thank you very much for watching it.